So this video is going to go through the different review problems. We didn't get to all of them. I'm going to hit some of the first ones kind of quickly, and then we'll move on from there. So multiply these. You simplify, write both of them as powers of 3, and then raise the power to a power by multiplying. So 10x plus 12x. Most common error here is to multiply and get 120x squared. Just remember that when you raise power to power, you multiply, but when you're multiplying exponents, you add the exponents. Factor or quadratic or whatever you got to do. This one ends up not factoring nicely. So completing the square is a decent method. And this is the method using quadratic formula. You could also factor out a 2. Whenever you're solving, you can divide both sides by something. Expand. We need Pascal's triangle, and then we expand the terms. So we have the first term raised to the 4th, and that would be negative 2 to the 0, 3x to the 3rd, negative 2 to the 1st. So you notice these powers are always adding up to 4. This is to the 1st. These add up to 4. So you expand everything out, and then you go to the correct row on Pascal's triangle. And if you forgot Pascal's triangle, any two numbers above, if you add them, you get the number below. So there's ones on the outside, and then it's just a matter of simplifying. So this 216 comes from 4 times 3 to the 3rd, which is 27, times negative 2. So a couple things to pay attention to. If there's a negative here, they're going to alternate between positive and negative. Simple rules. I would make everything positive before I start. So one thing that I do is try to make sure that my y to the negative 4th is written as y to the 4th in the denominator before I combine things. Negative 3 plus 7. I just make sure that you write this out. Don't just square both things. Write it out and multiply. Use your distributive property. Sorry, I don't have a good pen. And any I squareds become negative 1. You always end up with 2 terms. Factor. The completely part will cause some problems here, and that is because you have to take out a 2. So if you take out that 2 first, then you don't have to worry about it. Always look, you're not getting rid of it, you're factoring it. Synthetic division. So make sure you know how to set it up. I'm going to try to write with my mouse. Whatever makes this 0 is what goes over here. So 3, and then all of the coefficients are what you write here. And you make sure that if there's one missing, you put a 0. And then you bring down the first number, and you multiply and add. So I multiply, and I add, and I multiply, add, multiply, add. If there's no remainder left, then it went in evenly. It means it's a factor. Notice that my powers on my answer use the one less than the coefficient because we divided by x. So if I would have had an extra something like 3 out here as leftover, then I would have put plus 3 over x minus 3. But this one came out to 0, so there was no need. We need to have a perfect cube down here. Well, this is 5 squared. I wish it was 5 cubed. So I'm going to multiply both sides by cube root of 5 over cube root of 5. This is the perfect cube. Can't have radicals in the denominator, so this is 125, which is root of 5. Best way here is just multiply the first 2 together, and then take that times 4x, and that times 7. One way that I do this is after I multiply this out, I line up my terms. You can also multiply them out the long way. and then combine your like terms. The key is that you have like terms that you got to make sure you combine before you go on. Just distribute anything that is I, that can be taken I to the fourth, can be rewritten first if you want. So I can take any I to the fourth out of here. I can take I to the eighth out, and that just leaves me with a 3i. You want to simplify that way. Remember that our rules say, our imaginary number rules, we have I, and then I squared is -1. I to the third is I times -1, so -I, and I to the fourth is 1. And it always repeats. So 2i to the seventh, I can take out an I to the fourth, it leaves me with I to the third. So 2i to the seventh is the same as -2i. And then you simplify. We didn't get to this one. You have to simplify all your radicals. So radical 12 is radical 4 times radical 3. So this is 2 radical 3. And this is 7 times radical 4 times radical 5. So that's 2 radical 5. And this is 2 times 5 radical 3. At the end, you can combine like radicals just like their variables. So 10 radical 3 and 10 radical 3 can be combined, but these are not like terms, so we can't combine them at the end. 3x squared equals 36. This is more familiar, what we've been doing recently. Divide both sides by 3. X squared equals 12. Take the square root, plus or minus, and then simplify your radical. Fully factorize, that does not mean solve. That means just take and factor. I'm going to look at this, and first thing I'm probably going to do is reorder it as 3n squared minus 12. I'm more comfortable because that's how we usually have done this. Then factor out GCF. Remember that snowman model we had? At the top was always GCF. So take out the GCF. It's not disappearing. It's just being factored out. And then I can factor this into n minus 2, n plus 2. If I have a radical in the denominator with binomials, I need to multiply by the conjugate. So the conjugate of the denominator, because I want to get the radicals out of the denominator. If you multiply by the conjugate, what happens is we pick this conjugate because it's going to make the middle term go away. So in the denominator, we're going to have 64 minus 2. And then a key here when you go to simplify, if you want to reduce this fraction, you have to be able to take the same thing out of all three. So we can take a 2 out of all three of these. Can't just take a 2 out of one of them and be able to simplify. This, any power to power, -2 raised to the third. And then this is 7 to the 1/3. Losing my pen there. 7 to the 1/3 raised to the third. And then you can multiply your power. So that's going to be just 7. That's going to be -8. Just be careful here. Distribute. And then you're going to simplify. So distribute. Boom. Boom. Here. Here. Check to see if you can simplify your radicals. You can only combine like radicals. "128 feet of fencing, wants to enclose a pasture next to a barn. The barn will be one side." So we don't need fence along one side. All these